section 10.6, which is the last section in chapter 10, which, by the way, means that the next day you have a review, and after that you'll have a test. But anywho, section 10.6 is on trigonometry, the study of trigonometry. This is just an introduction to trigonometry. So we're looking at the rather well-known for many trigonometric ratios. Say that one 3 times really fast. Trigonometric ratios, trigonometric ratios, trigonometric ratios. Oh, I got it. Trigonometric ratios. These are the sine, cosine, and tangent. Don't let the names scare you. They're just ratios of 3 sides of a triangle. When you take a right triangle, if you divide like the length of A divided by the length of C, you're going to get a fraction, whatever it is, 3 over 4 or whatever. All right, you get a ratio of one length over another. It's a ratio. It's a fraction. All right, they just have names. We just give them names in math. So the ratio of A over C versus B over C versus A over B have these names: sine, cosine, and tangent. Well, it depends on which angle you're talking about. So here's the same triangle that I had for the Pythagorean theorem. A is the short side, B was the longer leg, and then C is the hypotenuse. C, remember, is always opposite the 90-degree symbol. And now these are lowercase, the legs and the hypotenuse length. Those are lengths of the triangle. The uppercase letters represent the angles themselves. And so angle A is the angle opposite its length. That's this A. Angle C is the right angle. We're only doing right triangle trigonometry. So angle C is the right angle, 90 degrees, which is opposite the hypotenuse. And then angle B is the one that's going to be opposite length B. They're always the angle, the corresponding angle is opposite its length. Length B, angle B. Length A, angle A. Okay? So here's Pythagorean theorem. I want to talk about this: sine, cosine, and tangent. And I'm going to look specifically at angle. This is the angle symbol. By the way, I'm on page 656. 656. That's the angle symbol. So the sine, which is abbreviated sine without the E, that does not stand for sin. It's sine of angle A. The sine of angle A is the ratio of the opposite side over the hypotenuse. So the sine of angle A is the length opposite the angle all over the hypotenuse. Sine is always opposite over hypotenuse. We can abbreviate that. Sine is opposite over hypotenuse. Sine opposite hypotenuse. Sine is opposite over hypotenuse. Sine of A is the opposite length over the hypotenuse. The cosine, which is abbreviated cos. The cosine of angle A is the adjacent. Adjacent is not the opposite one, and it's not the hypotenuse. It's the other one. All right. Adjacent leg, which is B in this case, the adjacent leg to angle A is the one that touches it, but it's not the hypotenuse. Hypotenuse always touches it, but the one that touches it, which is length B, the adjacent side, all over the hypotenuse. We can abbreviate that ka for so, ka, toa. So ka, that's the C cosine. C cosine, A adjacent, H hypotenuse. C cosine, A adjacent, H hypotenuse. And then the tangent of an angle is opposite over hypotenuse. For angle A, opposite leg over adjacent leg. All right, A over B in this case. Opposite leg over adjacent leg. TOA, tangent, opposite, adjacent. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And you'll hear people talk about this as a way to remember it, SOHCAHTOA. SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, SOHCAHTOA. Okay, so let's say we have an example where we have 9 and 15, and what's length B, and then what are the trigonometric ratios for angle A. So just to practice trigonometry here, to practice Pythagorean theorem, 15 squared equals 9 squared plus B squared. So this is 81. I've done this before, I think. It looks familiar. No, not quite. So B squared is going to be what? 220. Oh, yeah. 220. Yeah, I did it again. 225 minus 81, which is 144. Oh, that's convenient. Oh, that makes sense. Yeah. This is a version of a 3, 4, 5 triangle. Anyhow, 144. And if I take the square root of both sides, remember that you can't have any negative lengths. And so B is equal to 12. All right, so we know that B is equal to 12. Now, let's go ahead and find the angles. Not the angles, the sine, cosine, and tangent of angle A. Okay, so the sine of A, that's the shortcut way of writing that. Again, here's the way this is the official way of writing it, but we typically abbreviate it that way, is going to be the opposite side, which is 9. The opposite side, here's the angle, the opposite over the hypotenuse. Angle is right here. Sine of A is opposite over hypotenuse, 9 over 15, which reduces, because that's 3 times 3, and that's 3 times 5. So that reduces to 3/5. The cosine of angle A is going to be the adjacent side, which is B. The adjacent leg to angle A is this one right here, the one that touches it. It's the line that goes from the angle in question to the right angle here, all right? Not the opposite. So that's 12 all over 15. So 12 is 3 times 4. 15 is 3 times 5. So this comes out to be 4/5. And then the tangent of angle A is always the opposite over the adjacent, never the other way around, the opposite over the adjacent. So in this case, the opposite side of angle A is length A, over the adjacent side is length B, and so that is 9 over 12. Well, 9 is 3 times 3, 12 is 3 times 4, so this reduces to 3/4. That is how we do that. If you have something on your, if you were ever asked to find just to change this up, let's say that they want you to find a missing angle. Well, that's 42 degrees. This is 90. So that would be angle B. So angle B is equal to 42 degrees. You know that angle C by definition is 90 degrees. And you know that the angles must add up to 180. And so we can say that 180 degrees must be equal to angle A plus angle B plus angle C. So 180, I'm going to skip the degree symbol, must be equal to angle A plus, what is that, 132? If I subtract 132 to the other side, oh gosh, I should be able to do that in my head. So it would be 48, I'm not sure. Is that right? So, no, 38. Yeah. It's been a long day. 48, I was right. Okay. So I subtract that. So 180 minus 132 equals angle A. I'm going to just flip those around. So angle A must be equal to 48 degrees. There are a couple other things I want to do. If you're asked to find the cosine of angle B, well, angle B is 42 degrees. And you can use your calculator for that. So you have sine, cosine, and tangent right here. You might want to double check. It's a good idea to go into mode if you have any siblings that have been using this calculator. And ensure if you go into the mode, which is right to the right of second function, double check if you go down a couple, double check that it's in degrees and not radians. We are working in degrees. If it's not, if the degree isn't highlighted, go down and highlight degree, press enter, and then quit. So I can do, just type it on my calculator, just cosine 42, 0.74. The sine of 42 degrees. I'm going to have to end this in a second. The sine of 42 degrees. Just hit sine 42. Press enter. 0.67 to the nearest hundredth. Then you could do the tangent of 42. You're supposed to close the parentheses, but whatever. It comes out to be 0.9 or so. Okay, I'm going to close this. I have one more thing that I have to do, so I'm going to close this and do one more.